Hello student, welcome to the subject Analog and Digital Electronics, and here we are going to be started the unit 1 design of combinational circuits. In previous first and second modules we have to already cover the introductions about the cores and the various basic terms, and in module 2 we are cover the Boolean algebra simplifications, De Morgan's theory also. In this third modules we are touching to the K-map structure for the 2, 3 and 4 variable, as well as the SOP and PS forms reductions of the Boolean expressions by K-map. So let's recap the Boolean algebra, and we have to already studied. So Boolean algebra is a set of rules which is used to simplify the complicated Boolean algebra expressions. That is nothing but the Boolean algebra. But while solving the problems, it's a bit tricky. Why? Because it needs to be a skill of applying the rules and the laws, and we don't have any guarantee whatever the final answer you are getting is a most of the simplest form of expressions. So that's why the Boolean algebra method of simplification is not effective. So that's why we move to the another one methods for simplifications of complicated Boolean algebra expressions, and that's name is nothing but the Karnaugh map. As abbreviated, we call it as a K-map. But before we are touching to the K-maps, we have to touching to the basic terms, that is nothing but main terms, max terms, and SOP and PS form, and how it can be represented. And then we are started the K-map representations and K-map reduction techniques. The main terms. Main terms is a and terms to every variable present in the true or complemented form. The and terms is nothing but we call it as the product two terms also. So main terms is product terms, just keep in mind. So for main terms, whenever the one means the variable is not complemented, but in case of main terms, 0 means the variable is complemented, and this main terms is indicated by summation of small m. Small m is indicating the main terms, whereas in case max terms are or terms with the every variables in the true or complemented form. Or is nothing but we are sum terms. So main terms is the product terms and the max terms is the sum terms. For the max terms, 0 means the variable is not complemented, and the 1 means the variable is complemented. And this max terms is indicated by capital M, but with this sign that is nothing but the pi sign. So pi capital M and the summation of small m, that is the symbolical representations for the mean terms as well as the max terms. Let's see the example of the mean terms and the max term for the three variables. If there is a three variable x, y and z, in case of main terms, 0 means complement of that variable. Where seen here, the value of x is the 0 means x complement. The value of y is 0 means y complement. The value of z is 0 means z complement. And so on, the each and every preceding terms can be represented in case of main terms. See the last one terms where the value of x is the 1, value of y is the 1, and value of z is the 1. So that's why 1 means the not complemented variable. So that's why the x, y, z without complements it can be represented. While in case of designations of main terms, so that 0, 0, 0 is indicating a 0 decimal form. So it's a small m is the indicating the main terms, and the 0 is indicating it's representing the designation of 0. Similarly, in case of 001, so m1 is a designation for the main terms, and so for the preceding terms. In case of max term, the 0 is nothing but without complement terms, but the 1 is nothing but complement of the variables, and the max term is nothing but the summation or the sum of all the variables, and the main terms is nothing but a product of the all variables. So here it's a and logic functionality between the x, y, z. Here in this case shown here, the or logic functionality between the x, y, z is there. That is the max terms and the main terms. The designation as the small m is indicated for the main terms. Similarly, in case of max terms, capital M is indicating as a designation, and for 0 to 7 it can be indicating like that. So just keep in mind, so main terms, the 0 is complemented, whereas max terms 0 is not complemented, and vice versa. Now the standard form of the Boolean algebra expressions, regardless of their forms, it can be converted into either a two standard forms. We call it as the sum of product form and the product of sum form. In short, we call it as the SOP form, and the second one, product of sum, is nothing but POS form. So SOP and POS form, that is the two standard form of the Boolean expressions, is available. And for proceeding slides, we are going to be seeing what is the sum of product and POS. Now the SOP form. The SOP expressions, when two or more product terms are summed by a Boolean additions. Means we are taking the examples. Here the A and B are the first product terms. Then A, B and C, these are the second product terms. So these two product terms are related to each other by this sum. So it's a sum of these two product terms. So we call it as a sum of product. Similarly, in case of the second examples, this is the ABC is the first product terms, CDE is the second product terms, and the B bar CD bar is the third product terms, and they are correlated to each other by sum. So it's a sum of these three product terms. Similarly, this is the sum of these three product terms. Similarly, for this last examples, there is a single variables, but it's not a product. So even though we call it as the product terms, because we have to well known that, so A ANDed with 1, we are getting the A output. So here is A single variable is also a product term. So A is here the first product terms, A bar, B bar, C is the second product terms, B, C and D bar is the third product terms, and they are summed to each other. So that's why the sum of these three product terms. So we call it as the sum of product form, and it can be represented like that. That is the very important terms. In SOP forms, the whole complements is not allowed. If the individual complement, then it's okay. Here example is shown, the A complement individually, B is individually complemented, C is individually complemented. So then this product terms is okay or allowed, valid terms in case of SOP form, but the whole complement is not allowed. General expression for SOP. Any logic expressions can be changed into the SOP forms by applying the Boolean algebra techniques. We have to see one of the examples here. The first example is nothing but A is ANDed with this bracket B plus CD. So A is ANDed with the B and A is ANDed with the CD also. So we are getting the AB is the first product terms, which is sum with the second product term ACD. So this is the sum of these two product terms. So we call this as the sum of product, that is the SOP. Similarly, for the second examples, here outside B from the bracket is ANDed with the CD. So we are getting a BCD, and the B is again ANDed with the EF. So we are getting the BEF here also. So here we are getting the three product terms. First product terms is the AB, second product term is the BCD, third product terms is the BEF, and this can be summed to each other. So that's why it's a sum of three product terms. So that is the SOP again. So each and every logic expressions can be changed into the SOP. So these two brackets are multiplied to each other as like our mathematics. Okay, so we are getting AB or with AC or with AD or with BB or with BC and or with BD. So there are the 6 product terms and they are the sum of 6 product terms. So we are getting any logic expressions into a standard or SOP form. Similarly, for the whole complements, if we are apply the De Morgan's theorems, Boolean algebra De Morgan's theorems, we are breaking the whole complements and changing the signs. So, and the double complement is nothing but the same output we are getting. So we are ending the A C bar and we are ending the B C bar. So we are getting the first product terms as the A C bar, which is sum with the BC bar. So the AC bar is the first product terms and BC bar is the another product terms which are the sum. So we call it a sum of these two product terms. So these are the general expressions. Now let's move to the standard SOP. Standard SOP is nothing but all the variables in the domains appears in each product terms. We have already studied the product terms. There are 2 product terms, 3 product terms, or more than 4, 5 product terms is also there. But each and every product terms need to be required all variables contained. For examples, we are taking there are the three product terms is there A, B, C, D. In case of second product terms, the variable ABCD is available. In case of third product terms, the ABC bar D bar is available. Whether the variable is complemented form or non-complemented form, but the presence of variable in each product terms is necessary in order to define the standard SOP forms. The standard SOP is nothing but all the variable is present in each and every product terms. Standard SOP expressions is very important because we are going to be construct the truth tables, and the truth tables is very important or very helping for simplification methods of the K-map. We have seen in the preceding slides. Now what happens if there is a non-standard SOP form is available and you have to convert that non-standard SOP into a standard SOP. So there are some steps. So first steps is there, you have to multiply each non-standard product terms by the terms made up of the sum of missing variables and its complements. Now this results in the 2 product terms, and how it can be results in the 2 product terms we have to see in with the examples. But what is the second step? The second step is nothing but you have to repeating the first step until up to you are getting the resulting product terms as a standard SOP form. We are taking the one examples how we are converting the product terms into a standard SOP, non-standard product terms into a standard SOP forms. So these are the non-standard SOP form. Why these example is the non-standard? Because we have to clearly seen that during these all the product terms we have to see there are the 4 variables is available, but in case of the first product terms the D variable is missing. In case of the second product terms C and D is missing. In case of the third product terms all variables is present. So the first product terms and the second product term is not in a standard format or not in a standard SOP form. So we have to convert the first 2 product terms into a standard SOP form. And how we are converting? We are ANDed the missing variable or in with their missing variable complements. How? So see here. So first A, B bar, C, where the D is missing, so that D is ORing with D complements, and this is the ended with the remaining expression. So we are getting A, B bar, C, D ORing with A, B bar, C, D bar. So in this case the A, B bar, C is split into a 2 standard form. Okay, so whenever you are converting a product terms into a standard SOP forms, then always each and every single missing variables is converted into a 2 standard SOP form. Okay, so in second product terms the C is missing, also the D is missing, but we have to proceed for the C missing. So C ORing with the C complements, and it can be ended with the remaining A bar, B bar. So we are getting the A bar, B bar, C or A bar, B bar, C bar. Now this A bar, B bar, C, again the D is missing, and A bar, B bar, C, this is again the non-standard because of the D is missing. So that missing variables we have to again ended in the form of the missing variable ORing with the missing variable complements to the remaining expressions, and we are getting for this single A bar, B bar, C, we are getting these first 2 standard SOP forms, and for that second product terms A bar, B bar, C bar, for this non-standard we are getting a standard two product terms like that. In this case, we are converting the non-standard product terms into a standard SOP form. So finally, we are getting this non-standard SOP form is converted into the standard SOP form. So one kept in mind, in this standard SOP form, if any one product term is repeated, then one of the product terms is you are going to be neglected, because we are already studied the Boolean algebra rules. So A or A, we are getting the A. Now move to the product of sum. The product of sum, when two or more sum terms are multiplied and the result expressions is a product of sum. We are taking the examples. These are the first examples. This A bar is ORing with B, that is the first sum terms. A ORing with B bar ORing with C, that is the second bracket, which is nothing but a second sum terms. The first sum terms and second sum terms are related to each other because of this dot operations, nothing but we call it as the product operation, or we call it as the ANDed operations. So it's a product of sum terms. The sum terms is available and we are taking the product of that two sum terms. Here in this case, second examples, A bar B bar plus C bar is the first bracket is nothing but first sum term, second bracket is indicating the second sum terms, and the third bracket is indicating the third sum term, and that sum terms we are getting the productive form. So it is the product of these three sum terms. Another, in case of the third examples, there are again the three sum terms, and this nothing but the product of these three sum terms. Also, if there is a single variables outside the brackets, so we are considering this as a sum terms, because we have to know that any variables is ended with same things, we are getting the output as the same things. In case of POS form, the whole complements is again not allowed, not valid in case of POS also. Here in this case, A individual complements ORing with B individual complements ORing with C individual complements, so it's okay, it's allowed, it's valid. But the whole complement of the A ORing with B ORing with C and whole complements, so this whole complement is not allowed in case of POS form. There are again a standard POS form is there. The standard POS form is nothing but all the sum terms contain all the variables like that. Here it can be showing the first sum terms A, B, C and D, all the four variables are contained in this first sum terms. Similarly, in case of second sum terms, A, B bar, C and D, all the four variables is contained. Similarly, for the third sum terms, all the variables is present. So each and every sum terms, all the variable must be present. So we call it as a standard POS form. And the standard POS forms are very important for the constructing truth tables as well as the K-map simplification methods. Now, how we are converting if the non-standard POS is there and you have to convert it into a standard POS. So just keep in mind this rule number 12 is A is ORing with BC, we are getting A or B, which is ended with A or C. So how we are using this? So we have to directly see in the examples how we are converting non-standard to standard POS form. Now see here, A B bar, A ORing with B bar ORing with C. Here the B bar, C and D bar is there, means you have to conclude that this expression having a four variable, in the first sum terms D is missing, and in the second sum terms the A is missing, while in case of third sum terms no variable is missing, all the four variables is available. So the first sum terms and second sum terms you have to working on it. So first sum terms we are taking here and we are ORing the missing variables ended with their missing variable complements. So missing variable for the first sum terms is the D. So A or B bar or C, we are ORing the missing variable D ANDed D complements. And how it can be, we are getting the standard form. So A or B bar or C, we are ORing the D. That is the first terms we are getting as per according to this Boolean algebra expressions. A is ORing with BC, we are getting the A or B ended with A or C. So similarly, in this case, if we are A ORing B bar ORing with C, which ORing with D, so we are getting the first standard sum terms. Similarly, for the second sum standard, we are getting using these rules. For the second sum terms, the A is missing, so that missing variables ended the complement of that missing variables, we are ORing with the remaining expressions. So the B bar, C and D bar is ORing with A ANDed A complements, and we are getting the two standard sum terms. Now we are putting these sum terms in these expressions, and finally we are getting, for the first non-standard we are getting a two standard sum terms, and for second non-standard sum terms we are getting again the two standard sum terms. So first for 2, second for 2, and lastly the 5. So in this way the 5 standard Pierce form terms we are getting. So in this way we are going to be converted non-standard pairs into standard pairs. Converting a standard pairs to standard pairs, converting a standard SOP to standard POS. So how we are converting? So there are the steps is given. First you have to evaluate the product terms in the SOP expressions, that is determined by the binary numbers that is represented in the product terms. But how it can be represented, we have to see in directly to the examples how we are converting the standard SOP to POS. Now let's take the one example, one of the expressions. Which form is this expression? So this expression is the sum of these product terms. So it is in SOP form. So in this SOP form expression, we have to convert it into equivalent POS forms. Is nothing but you have firstly evaluating is at in case of 0 1 0 1. So in case of SOP, the complement is nothing but 0, where the A complement is nothing but the value of A is the 0. The B complement is nothing but the 0. C complement is nothing but the 0. So the A bar, B bar, C, we are getting a 0 0 0. Similarly, in case of A bar, we are getting again the 0, where the B is not complemented, so that's why its value is 1. C is complemented, so again this value of C is 0, and so on for the proceeding product terms. So A bar is nothing but 0 1 1, that is the 1 0 1, and this is the 1 1 1, because no one variable is complemented here. So the 3 variable is there, so possibility of 3 variables, input possibility for the 3 variables is 7. The input possibility for 3 variables is 8, and we are getting only the 1 2 3 4 and 5 terms. So the possibility, total possibility for 3 variables is the 8, and we are presenting here only the 5 terms, means remaining 3 terms, which is 0 0 1 1 0 0 and 1 1 0, which is a PS form. Means first we are taking the SOP expressions, and from the SOP expressions we are evaluating the SOP terms, and remainings are POS terms is there. So POS terms, in case of POS, the 0 is nothing but not complemented, but in case of POS 1 is nothing but complemented. So the 0 value is nothing but the A, which is ORing with the B value is again 0, where the 1 is representing complement, so C is getting to be a complemented here. Here in case of 1, so the value A is complemented, 0 0, that is the B and C is not complemented. 1 1 0, so the A and B is complemented, but the third variable, that is the C, is not complemented here because it's a 0. In this way we are getting the remaining 3 value for the POS form. So these are the expression for the SOP, and if we are converting into PS, we are getting this 3 POS form expression. Now Boolean expressions and the truth tables, we have to convert the Boolean expression into truth tables and vice versa, truth tables into the Boolean expressions. And how it can be converted, we have to see in the proceeding slides. We have to see here how we are converting the SOP expression into the truth tables. These are the SOP expressions is there: A bar, B bar, C. The second product terms is the A, B bar, C, and the third product terms is the A, B, and C. These product terms we are representing in these tables is like that. Why? Because in case of SOP, the complement is nothing but 0. Where the A complements, so value of A is becomes to be 0. So there are the 4 possibility where the value A is 0. Now for the B is complemented, means complement is nothing but 0 in case of SOP. So the B value, only these 2 possibilities there. Okay, so this 2 is cancelled out. Now the A value for the first 2 row, we are just selecting which one is the A bar, B bar, C. Now the third C is nothing but without complements is nothing but its C value is the 1. So the 0, 0, but the C value is 1. So we are getting the second value 0, 0, 1. So it can be indicating A complement as a 0, B complement as a 0, and 1 is nothing but the C is without complements, no complements. So similarly for the A, B bar, C, so A is the without complement is nothing but 1 values like that. This 4 possibility is there. This 4 low is there. B complement, nothing but B complement is nothing but 0. So out of this 2 row, it can be possibility for this product terms. And the third C is giving a C complement. So C complement is nothing but the 0. So C complement is nothing but 0. So A is 1. B complemented means 0, C is complemented means 0. So 1, 0, 0. So that is the A, B bar, C bar. Similarly for the ABC, there is no complement for any variable. So 1 for A, 1 for B, and 1 for C. So 1, 1, 1. So that is the ABC product term. So these are the product term. And for the each product terms, we always represents 1 as the output in case of SOP. So that's why these are the product terms or SOP terms: SOP1, SOP1, SOP1. So remaining R is nothing but POS, because there is possibilities like that. The SOP terms, if you find out, then remainings are the POS terms, and once if you find out the POS form, then remainings are the SOP form terms. So these are the converting how the SOP expression into truth table. So this SOP expression is available. So firstly we have to find out the SOP product terms from their complement. If there is a complement, so we are taking a 0. If there is no complement for the variable, we are taking as a 1 for SOP. And in this way we are getting the output for the each and every product terms. We are representing 1 and remainings are 0, that is nothing but the POS form. Now let's converting the POS expressions to the truth table format. In this truth table format, the standard POS expression is available here, and one of the main points you have to keep in mind in case of POS, so without complement is nothing but 0 value, and with complement variable is nothing but the 1 value. So in the first sum terms, the A, B, C, all the 3 variables are without complement. So that's why the value of A is 0, B is 0, and C is 0. So from the truth tables, where is the value of A, B, C is the 0. So the first here, the value of A, B, and C is the 0. So the first sum terms are presented here. Here the product terms I am writing here, but it's not a product terms, it's a sum terms. We call it as a sum terms. So the first terms we are represented here. Similarly, if we are seeing here the last sum terms, A complements is nothing but 1, B complements is nothing but 1, and C is nothing but 0. So 1, 1, 0. So value of A complement is 1, B complement is 1, and C is nothing but without complements, so it's giving to be a 0. So it's a 1, 1, 0. So last sum terms we are represented here. So in this way we are representing the product terms, sum terms here, and the sum terms output is the 0. The output we are representing here the 0, and remaining all the terms is nothing but the output producing the 1, nothing but the SOP terms. So determining the standard expression for the truth tables. So keep in mind, in case of our the SOP expressions, 1 is corresponding variables and 0 with corresponding to variable complements. Means you have to just keep in mind SOP, the 0 is complement and 1 is without complements. Now converting this 1010 in SOP, so we are getting 1 is without complement, so value of A is without complement, and the value of B is nothing but complements, and the value of C is without complement, and value of D is nothing but the complemented. In case of POS expressions, we are getting the value of 1 with the variable complements and the value of 0 without complements. So the 100, it can be represented like that. 1 is nothing but the variable with complement and 0 is nothing but without complementing variables. So similarly, in case of SOP and POS, we are going to be determining the standard expression for the truth tables. Now vice versa examples we are seeing. In previously we were converting SOP or PS form into truth tables, and in these examples we are converting truth tables into SOP or PS form. In case of SOP forms, we know that 4 ones we are presented here. In case of this output 1, in case of 0 1 1, in the second ones it's a 1 0 0, and third ones it's a 1 1 0. So keep in mind, in case of SOP, 0 is nothing but the complement of that variable. So 0 for this C is complemented, B is complemented, but the A value is 1 is nothing but without complement. So without complement A value, but the B and C is complemented for this first terms. Okay, so 0 1 1 is nothing but A complement BC, and 1 0 0 is nothing but the A B complement C complement, because the value of B and C is the 0. In case of SOP, 0 is the complement. Similarly for the proceeding one, and this is the SOP, that is nothing but these are the product terms is available, and we are sum that all the product terms we are getting the expression like that. So output X we are getting the first product terms, second product terms, third product terms, and the fourth product terms. We are summing all these 4 product terms in case of SOP. Now in case of POS, we have to find out the output as a 0. Where is the 0? So all the 4 zeros are presented here. These are the 3 first 0 and the single one zeros output presented here. In case of POS, you have to just keep in mind 0 is nothing but without complements and the 1 is nothing but the complements. So for the 0 0 0 is nothing but we are representing without complement of the A, ORing with B, ORing with C, because it's a sum terms. In case of SOP, it's a product terms. Okay, so 0 0 1, so 0 is nothing but without complement, so A is without complement, B is without complement, but the value of C is the 1, so that's why we are taking the C as a complement. Similarly for the 0 1 0, so the A is without complement, the value of B is 1, so that's why we are taking the B as a complement, and so on further. Now we are representing it into POS form. POS is nothing but the product of sum. These are the sum terms is available, and we are making the product in between relation between all these 4 terms. So the X expression we are getting POS form expression same way. So this is all about the POS SOP and expression, how we can converting the POS into SOP or SOP into POS, and how we can representing into a truth tables and truth tables into the various SOP and POS forms. If you have any query, so ask me anytime on my Gmail, on my official madhusri.education.in mail ID, or my WhatsApp personal WhatsApp number. Thanks for watching this video.